Okay, so we're going to find the intervals of concavity and inflection points. So, whoopsie. Okay, so to find the intervals of concavity, we need the second derivative. So let's do that first. So the first derivative, let me make it a little thicker. The first derivative is going to equal to, so it's 1 over the inside of the log, so 1 over 1 minus ln of x, times the derivative of the inside, which is going to be, so this is 1 over, times negative 1 over x. Okay, so let me simplify this a little bit. So this is going to be negative 1 over x times 1 minus ln of x. Okay, and then the second derivative, so we need to get the derivative of this guy. Let's do that. So if we do the quotient rule, what we get is the derivative of the of the top, which is going to be just 0, times the bottom, minus the top derivative of the bottom. And the derivative of the bottom, we have to do the product rule, so we get the derivative of the first times the second. We're going to have a little bit of simplifying to do, plus the first times the derivative of the second, which is minus 1 over x. Okay, so this first guy, this is 0. And then here, these guys are positive 1, so that's 1 times. And then in the inside, we have 1 minus ln of x. This guy is just equal to negative 1. And so we get 1 minus ln of x minus 1. So this one cancels with this one. And so we get negative ln of x on top. Oh my gosh. You see the checkerboard. Oh well, I don't care. So we have minus ln of x. And that's going to be over, I forgot, all this is over the denominator squared. So all over x times 1 minus ln of x. And that whole thing squared. Okay, so that's good. So that's my second derivative. And so we set that equal to 0 to find my, my pips. So let's write them down over here. My pips so we've got from the top, so ln of x equals to 0 when x is equal to 1. So that's good. And then if I solve the bottom, I get that another pip when x equals to 0 from this one. And then from this guy, when x is equal to, if you solve 1 minus ln of x equals to 0, you get x is equal to e. So you have 3 pips, 0, 1, and e. And so let's do our number line here. Okay, so number line. And then let's put down our pips. 0, 1, and E. And let's do some test points. We can do -1, and then 1/2. And then right here we can do 2, and then here we could do 3. Now, notice that my original function it's not defined for values of x less than 0. And so this guy is just not in the picture at all. So my function isn't even defined here, so I don't even have to worry about that. And even if I try to plug it in, I just get nonsense. Okay, so let's try to plug in 1/2. Now if I plug in 1/2 into the second derivative, what I get is that that guy is going to be, so negative natural log of 1/2 over, and then the denominator, this whole thing is being squared, so this is just going to be positive. And so natural log of 1/2, this is going to be negative times the negative, so this is going to be positive. So what this means is that this guy is going to be concave up on that interval. Now if I plug in 2, I get negative natural log of 2 over, again, positive. Natural log of 2 is positive, so this guy is going to be negative. So negative, which means that this guy is going to be concave down. So what I have here at 1 is I have a inflection point. And then let's do one more. At 3, I'll plug it in and you get negative again, which means that it's concave down, so no inflection point there. So this guy is an inflection point. At 1, comma, and if I plug in 1 into the original, which is up here, you'll notice that ln of 1 is, ln of 1 is 0, so then we get inside 1 minus 0, so ln of 1 minus 0 equals 0. So my inflection point is at 1, 0. And so then my intervals of concavity are, it's concave up from the interval from 0 to 1, and then concave down from 1 to infinity. And that's it. Now, actually, we have to be a little bit more careful. We didn't find the domain in the beginning. Hey. Oh, there it is. That's weird. Oh, okay. Sorry. So, anyways, this guy, notice that this guy right here, so this is only defined if this inside part is greater than 0. So if you look at this and you ask yourself, 1 minus ln of x greater than 0, well, that would mean that ln of x would have to be less than 1. And the values for which ln of x are less than 1 is from 0 to e, because ln of e is 1. So once you go past e, then this function is actually not defined anymore. So here, this was a non-issue as well, and so that's why you should always find the domain first, because you never know. So this is actually a little incorrect. Let's do this. Should be from 1 to e, because that's the only spot that my function is defined to. And then that's it.